In this video, we're going to find square roots of perfect squares using only numerical examples. We'll save examples of variable expressions for another video. So let's start with the example on the far left. The instructions say to simplify each radical without using a calculator. And the first example that we have is the principal square root of 16. Remember, if we don't have a sign in front of the square root symbol, that means we're looking for the principal square root or the positive square root. So if we want to find the square root of 16, we want to find the number that when we multiply it times itself gives us 16. Well, there are two of those numbers. One is positive 4, one is negative 4. But we only want the principal square root in this example. So the principal square root of 16 is 4. Let's look at the second example. Here we're asked to find the negative square root of 4. Well, there are two square roots of 4, positive 2 and negative 2. But in this example, we only want the negative square root. The negative square root of 4 is negative 2, because negative 2 times negative 2 gives us positive 4. The next example asks us to find the negative square root of 0.0144. When I'm finding the square root of a decimal number, I only look at the non-zero numbers in that expression. So in other words, here I'm going to look at the number 144. Well, I immediately recognize that 144 is 12 times 12. So the square root of 144 is 12. But we're looking for the negative square root of this number, so that would be negative 12. But negative 12 times negative 12 is 144, not 0.0144. So the next thing I do is count the number of decimal places in my radicand. Well, in our radicand, we have 1, 2, 3, 4 decimal places. To get a 4 decimal place number, I would have to multiply a 2 decimal place number times itself. So in other words, I would have to multiply 0.12 by 0.12 to get 0.0144. Because a 2 decimal place number multiplied by another 2 decimal place number will always get me a 4 decimal place number. Or you can think about it this way. The number in the radicand is the number 144 10,000ths. To get a number that is 10,000ths, I would have to multiply hundredths by hundredths, tenths, hundredths. So 12 100ths times 12 100ths is 144 10,000ths. And of course, if you need to double check yourself, you can always use your calculator and just multiply negative 0.12 by negative 0.12, and you should get 0.0144. Let's look at the last example. In this example, we're looking for the principal square root of 1/4. So what fraction times itself would give us 1/4? Well, 1/2 times 1/2 gives us 1/4. So the principal square root of 1/4 is 1/2. Let's take a look at these examples. On the very far left over here, we're asked to find the principal square root of negative 9. So we need to find a positive number that when multiplied times itself gives us negative 9. The only positive number that when multiplied times itself gives us any form of a 9 at all is 3. But 3 times 3 is positive 9, not negative 9. As a matter of fact, it's impossible using real numbers to find the square root of any negative number, because a positive times a positive will always be a positive, not a negative. And even a negative times a negative is a positive, not a negative. So for the purposes of this class, because we've not covered the complex number system yet, anytime we are asked to find the square root of a negative value, our answer will be that that is not a real number. Now, the reason that our response is not a real number is because the square root of any negative number does exist. So therefore, we can't say does not exist. It does exist. It's just not a real number. This number, the square root of -9, belongs to another number system called the complex number system, which we haven't studied yet. More specifically, the square root of any negative number is called an imaginary number. Therefore, it is the opposite of a real number because it's imaginary. Imaginary numbers exist? Yes, they do. But we've not studied them up until this point. So our response, anytime we have the square root of a negative value, will be not a real number. The next example asks us to find the principal square root of 11. Now 11 is not a perfect square, but does the square root of 11 exist? Yes, it does. It's just not what I call a nice number. So if we want to find the value of the square root of 11, we're going to have to use our calculator. So take out your calculator and type in the square root of 11 and see what you get. When you do that, you're going to get what we call an irrational number. The square root of 11, because 11 is not a perfect square, will give us an irrational number. What's an irrational number? An irrational number is a number that when we write it in decimal form, that decimal never establishes a repeating pattern, nor does it ever end. So we say that it is non-repeating, non-terminating. So the square root of 11 does exist, but the result of square root of 11 is a non-terminating, non-repeating decimal. It goes on forever. So when we come across these types of examples, the best that we can do is use our calculator and then round according to how our instructions tell us to round. Here we're asked to round to 2 decimal places if we have an irrational square root. So when I type in square root of 11 in my calculator, I get 3.31662479036 and so on. It never ends and it never repeats. If I round that to 2 decimal places, I'll get 3.32. So the square root of 11 is approximately 3.32. So in other words, 3.32 times 3.32 will get me really, really close to 11. Let's take a look at the last example over on the right. Here we're asked to find the negative square root of the quantity -4 squared. Now here's one last thing that we need to know about the square root symbol. The square root symbol can also act as a grouping symbol. In other words, the square root sign may have some operations underneath it that need to be completed before we can actually find the square root of the number underneath. Again, we're asked to find the negative square root of the quantity -4 squared. Well, I've got to figure out what -4 squared is before I can find the negative square root of that. Well, -4 squared is -4 times -4, which is a positive 16. So I need the negative square root of 16. Well, that is -16.